Welcome to Theory of Computation. Here I am going to give an introduction about 3 CNF SAT problem. So it is also called as Boolean satisfiability. And another name for Boolean satisfiability is Cook's theorem. So if you consider a Boolean formula, that is for in a circuit, some logic gates are available which contains OR gates and AND gates. For that we are using Boolean formula as OR notation and AND notation. So if you consider literal, what is a literal means? A literal is an occurrence of a variable or its notation. For example, if I am taking one input as x and another input as y, the possible literals are x, otherwise x dash, its negation, and y dash, its negation. So these individual values are treated as literal. And class means a combination of literals. So how can we combine those literals means you can combine those literals by using R value. So what are all the possible? There are two variables are available, two literals are available, namely x and y, and its corresponding negation values are x dash, y dash. So what is class means? The combination of two literals. The literals may be either the same literal and its negation, otherwise two different literals. So the possible literals values are x, r, y. It is one class. And another class is x, r, x dash. Next possibility is y, r, x dash, or y, r, y dash. So these are all treated as class. So it is a single variable is treated as literal, and the combination of two literals with OR symbol is treated as class. CNF means and of those classes. That means it is one class and this is one class. So I want to combine these two classes with AND formation means it is called as CNF. So for example, I am taking x1, x2. It is one class, x1 or x2. It is x class. Negation of x1 or x3. It is a second class. x2 or negation of x4. This is the third class. So I want to combine these three classes with the help of AND operation. So it is called as CNF. But in this CNF, each class contains only two literals in it. So it is called as 2 CNF. What is the meaning of 3 CNF? Means each class should contain 3 literals. If you frame 3 literals in a class, then it is called as 3 CNF. So it is an example for 3 CNF. So here pi is equal to x1r, negation of x1r, negation of x2. So there are 3 literals are available which will be combined with a single class. So this class contains 3 literals. Second class contains 3 literals. Like that, third class contains 3 literals. So the combination of more than one class with 3 literals, it is called as 3 CNF. Okay. Then what is a 3 CNF SAT problem? So we want to take a Boolean formula pi, and this Boolean formula pi is framed in a 3 CNF form, and we want to check whether it is satisfiable. When you say this pi is satisfiable means if the answer of pi is 1, it is satisfiable. If the answer of pi is 0, it is unsatisfied. This is the two logic. Then consider 3 CNF, whether it is satisfiable problem or an unsatisfiable problem. This is the major question. So if you consider the same example, pi equal to x1r, negation of x1r, negation of x2, and x3r, x2r, x4, and negation of x1 or negation of x3 or x4. Here there are 4 different literals are used and its negation values are negation of x1, negation of x2, negation of x3. So these values are used for framing a 3CNF value. Here I want to check whether it is satisfied. So if the result should be 1, then I want to change the answer of x1, x2, x3, x4 as either 0 or 1 combinations. So I try the all possible values for putting x1, x2, x3, x4 values as either 0 or 1. So consider I am taking x1 and x2 as 1, x3 and x4 as 0. This is for example. So I substitute the value in this 3CNF notation. So it is 1 or negation 1 means 0 or negation 2 means 0. And x3 is 0 or x2 is 1, x4 is 0. This is the second notation, second class. Third class answer is it is 0 or 1 or 0. So it is an OR combination. If any one of the value is 1, the answer is 1. The first class answer is 1. Second class answer is 1. Third class answer is 1. These 3 classes are combined with AND notation. So the final answer is 1. So it is a satisfiable problem with the value as x1 equal to 1, x2 equal to 1, x3 equal to 0 and x4 equal to 0. Then I am taking another example as x1 1, x2 1, x3 0 and I am taking x4 as 1. So substitute the value here. It is 1 or 0 or 0. So the answer is 1 for first class. Second class x3 is 0, x2 is 1, negation x4 is 1. So the answer is 1 for second class. In third class negation of x1 0, negation of x3 1, x4 value 1. So the answer is 1. Final answer is 1. So pi is 1 for this values also. Like that we want to check the value. So here I am taking x4 as 0 or 1. So if x4 is 0, it is satisfied. For x4 is 1 also it is satisfied. Then I try to check the x3 value. Here I am taking x3 value as 0. So instead of that you should substitute x3 value as 1. So I try the next one. If I am substituting x3 is 1, for the first one the answer is 1. Here the answer is 1. Here also if you take negation of x1 it is 0. x3 negation of x3 means 0. If I am taking x4 is 1 only, the answer will be taken. So like that we want to combine, consider all the types of zeros and 1 values for these 4 variables and if it is satisfied 1 means it has a solution. So if you consider 2 CNF problem, it can be easily solved in a polynomial time. But if you consider a 3 CNF problem, we try to put the different possibilities of values for the given variables. In this example, there are totally 4 variables are used. So it's not necessary to use all these 4 variables. Instead of that, we can able to use 6 variables or 8 variables depending upon the size of the circuit. So depending upon the number of variables usage, then the solution of 3 CNF will be taken as either NP complete or NP hard. So if you consider 3 CNF problem generally, it will able to find a solution at a particular situation. So all 3 CNF problems are treated as NP complete. So NP problems are reduced as a satisfiable problem and that problem can be reduced as 3 satisfiable problem with this notations. So 3 CNF SAT problem can be verified within a polynomial time under some conditions. So how can we implement the polynomial time reduction means by simply replacing each variable in a formula with its value. So instead of x2, x3, I am substituting as either 0 or 1. So by substituting the integer value instead of that variable, we can able to find a solution. So this is the evaluation of 3 CNF problem. and consider the satisfiable problem. All satisfiability are treated as a polynomial reduction. So how can we prove it? For example, this is one circuit which contains three variables x, y, z, and y and z are with and notation, x and y z are with r notation. So instead of r, here the symbol plus is used, instead of and the dot symbols are used. So if you consider this notation, I am substituting the properties. So here with the help of distributed property, I can able to rewrite that expression as x plus y or x plus z, because dot is considered as AND operation. Then I can able to, this is a 2 class value 2 CNF. I want to write it as a 3 CNF format. So plus means r. So I am writing z dash. So z dot z dash. So z and its complement, if you combine those two values, the answer is 1 by using identity law. So I can able to write it as x plus y plus z dash. Here the missing value is y, so I can able to write it as y dash. So intermediate value is dot. Then again substitute intermediate distributive law. So we can able to rewrite this expression as x plus y plus z dot x plus y plus z dash. And the second class is rewritten as x plus y plus z dot x plus y dash plus z. So if you consider these four classes, so here dot is nothing but AND operation. Here the same class is rewritten. Instead of writing two different notations, I can able to write only single notation. So the final answer is x plus y plus z dot x plus y plus z dash dot x plus y dash plus z. So for any type of calculation, we can able to write a 3 CNF format by using the properties of laws. So in this way, we should write all the calculations in a 3 CNF format, and we try to find whether it is satisfiable or not with the help of substituting the value 0 or 1 to each variables in it. So all 3 CNF problems are treated as an NP complete problem. So it is also another example for NP complete problem. So if you consider polynomial problem algorithm is Kruskal's algorithm. If you consider NP complete problem, there are two problems are available. One is traveling salesman problem and another one is the 3 CNF problem. So in this lecture, I complete the TOC classes. I hope that you satisfy with this notations. So if you have any queries, please send a mail to me. Thank you.